Flow and error control. Well, framing is not the end of all problems. Framing alone cannot guarantee precision. We've solved the problem of marking the start and end of each frame for now. But how do we know that all frames are actually delivered to the network layer at the destination, correctly, and in the proper order? The usual approach to ensure reliable delivery is to provide the sender with some feedback about what is happening at the other end. Generally, the protocol tells the receiver to send back special control frames having positive or negative acknowledgments about the receiving frames. If the sender machine receives a positive acknowledgment, that means the frame has arrived safely. And if it's a negative acknowledgment, it knows that something is wrong, and the frame must be retransmitted again, until it is positive. And there is a possibility that the hardware troubles may cause a frame to vanish entirely, or if the acknowledgement frame is lost, the sender will not know how to proceed. In this case, the sender will wait forever for the acknowledgement. This problem would be solved by introducing timers into the data link layer. That means whenever the sender transmits a frame, it usually also starts a timer with it. The timer expires after an interval that is long enough for the frame to reach the destination, process there, and have an acknowledgement transmit back to the sender. If nothing goes wrong, the timer will be cancelled after acknowledgement reached the sender. If the frame or the ACK is lost in transit, the timer will expire, indicating the sender about the problem. The usual solution is to transmit the frame again. And there may be a chance that the same frame reaches the receiver multiple times after the retransmission. The data link layer passes these duplicate frames to the network layer. That's why the sequence numbers are introduced for the outgoing frames, so that the receiver is able to identify retransmitted frames from the originals. The mechanism of retransmission of frames, whenever an error is occurred, is called automatic repeat request, ARQ. Flow control. Another critical problem that occurs in the data link layer is, sometimes the sender transmits the frames faster than the receiver can accept. This problem occurs when the sender is running on a powerful machine, and the receiver is running on a low-end machine. Somehow, the receiving device must inform the sending device to slow down, or stop sending frames temporarily. For this reason, every receiving device must have a block of memory reserved for storing incoming frames, until they are processed. This memory block is called as buffer. The receiver tells the sender to halt transmission if the buffer fills up to the neck. There are so many flow control mechanisms and protocols out there. We will discuss them separately for noiseless, error-free, and noisy, error-prone channels. Noiseless and noisy channels. The data link layer uses framing, flow control and error control to transmit the data from one node to another. These mechanisms are done by the data link layer protocols. So, we will see how the protocols are implemented, and how they manage these mechanisms. We can classify the protocols into two categories. One is used for noiseless channels, where the probability of error is small, and the other is used for noisy channels. For better understanding, we will implement these protocols, one by one, starting from a basic implementation to the complex protocol, by solving the problems step by step in each of the protocols. Noiseless channels. Let us first assume an ideal channel, where no frames are lost, corrupted, or duplicated. We discuss two protocols for this type of ideal channels. The first type of protocol does not use flow control, and the second one does. And neither of them has error control, because we have assumed that the channel is perfectly noiseless. Simplest protocol. As an initial example, we will consider a protocol that is as simple as it can be, because it does not worry about the possibility of anything going wrong. The sending and receiving network layers are always ready. Processing time is ignored. Infinite buffer space is available. And the communication channel between the two data link layers never damages or loses frames. This is thoroughly unrealistic protocol, which we call simplest, because of the lack of any other name, and it is simply to show the basic structure, on which we will build the original protocols. The protocol has two distinct procedures, running in the source and destination machines. Both procedures, that is, sender and receiver, are constantly running, because they do not know when the corresponding events will occur. The sender is always ready, and pumps data out onto the line, as fast as it can. And the sender would be in sleep position, until there are some packets to transmit. If there are packets to send, it takes the packets from network layer. makes a frame by appending header and trailer to the data packet, and transmits the frame to the physical layer for transmission. The same procedure repeats for all frames. The receiver algorithm has the same format as the sender algorithm, except that the direction of the frames and data is upward. Takes data from physical layer, and extracts the data, then finally delivers data to network layer. If data frames arrive at the receiver side faster than they can be accepted, the frames must be stored, until their use. For this reason, the receiver must have a sufficient buffering space, and processing abilities. However, this is a worst-case solution, because it needs dedicated hardware, all the time even if the utilization of link is mostly low. An excellent solution to this problem is, to have the receiver provide feedback to the sender. The protocol we discuss now, is called the stop and wait protocol, because the sender transmits one frame, stops until it gets confirmation from the receiver, that is, OK to go ahead, and it then sends the next frame. As in the simplest protocol, the sender takes a packet from the network layer, uses it to construct a frame, and sends it on its way. But now, unlike in the simplest protocol, the sender must wait until an acknowledgement frame arrives, before looping back and fetching the next packet from the network layer. So, difference between simplest, and stop and wait protocol, at the sender side is, the sender waits for an acknowledgement, before sending the next frame. And receiver side is that, after delivering a packet to the network layer, the receiver sends an acknowledgement frame back to the sender.